Hey, welcome to The Explainer. Have you ever really stopped to think about what happens when you click on a link? I mean, really think about it? Today, we are going to pull back the curtain on that incredible, completely invisible journey your data takes every single time you go online.
It feels instantaneous, almost like magic. But in that split second, your request is literally zipping across the planet through this massive hidden network of cables and routers and servers. So we're going to trace that entire path, right from your finger on the mouse to the cloud and all the way back.
So here's our game plan. We're going to start with the absolute fundamentals, like what even is a network? From there, we'll follow our click as it leaves your house, shoots across the globe, and finds its destination. We'll also dig into the rules of the road that stop the whole thing from being total chaos. And finally, we'll look at why this invisible system has, well, completely changed everything.
All right, let's start at square one. Before we can even begin to talk about the internet, we have to get our heads around this simple but really powerful idea of a network.
At its most basic, a network is just a way to move information from point A to point B. Think of it as a digital message. That message gets turned into a signal, maybe a tiny pulse of electricity or a flash of light in a fiber optic cable, and boom, it's on its way.
And this is where the magic really starts. The second you connect these computers, they're not just lonely islands anymore. They can actually work together. They can share files, they can share software, they can even share a single printer in an office. This right here, this simple idea, is the foundation the entire internet is built on.
Okay, so let's get our click on the road. The very first step of its journey happens right in your immediate area, your network neighborhood, if you will. This is what we call a local area network, or a LAN.
Now, how does data get around in your local network? Well, way back when, you had these things called hubs. A hub was basically a town crier. It just shouted every single message to every single device. Kind of worked, but it was loud and super inefficient. Today, we use switches, which are way smarter. A switch is more like a postal worker. See, every device has a unique physical ID called a MAC address. The switch reads the address on the data package and delivers it only to the computer that's supposed to get it. It's targeted, it's fast, and it's a whole lot more secure.
All right, our click made it through the local streets. Now it's time to merge onto the highway. It's leaving our cozy little local network and heading out onto the internet itself, which is really just a gigantic network of other networks. So, just to recap, we start inside the LAN. That's our home base, right? It's the network that connects all the devices in one building or one office. Now, if you zoom out a bit, you get a metropolitan area network, or a MAN. You can think of this as connecting all the different LANs across an entire city. It's how a company's main office can talk to its branch across town, or how a university can link up all of its different campuses.
And then we have the big one, the Wide Area Network, or WAN. This is the beast that connects everything over massive distances. We're talking cities, countries, even continents. It's this huge patchwork of technology, like those giant fiber optic cables running under the ocean, that creates the global network we call the internet.
And this is really the key. If you remember one thing, remember this. The internet isn't one single thing. It's a network of networks, a massive, sprawling, decentralized web of all these LANs, MANs, and WANs, all connected and talking to each other.
So, how does our click find its way through this ridiculously complex web? Well, that is the job of the router. You can think of a router as the internet's GPS. It sits at all the intersections where different networks meet up. It takes one look at the destination address on your data packet and, in an instant, it calculates the best possible route to send it on, dodging all the digital traffic jams along the way. Okay, but think about it. You've got literally trillions of these data packets flying around the planet at any given second. How does it not all just descend into complete and utter chaos? Well, the answer is rules. A universal set of rules, a common language that every single device on the internet has agreed to speak. And that language is called TCP/IP. The easiest way to think about TCP/IP is like sending a package. The application layer, that's you writing the letter. It's the data coming from your web browser. The network layer slaps the to and from addresses on the box. The data link layer puts it on the right mail truck for the first part of its journey. And the physical layer, well, that's the actual road the truck drives on. And when it gets to the other end, the whole process just happens in reverse to perfectly reassemble your message.
And the absolute linchpin of this whole system is the IP address. It's so simple. Just like every house has a unique mailing address, every single device connected to the internet has a unique IP address. It's how the routers know exactly where to send every single packet of data.
Now, here's a little history lesson. In the early days, these IP addresses were grouped into different classes based on size. So a Class A network was for a huge organization with space for over 16 million devices. Class C was for a tiny network with just a couple hundred. The big problem? We ran out of these addresses fast. This class system isn't really used anymore, but it's a great example of how the internet had to evolve to keep up with its own insane growth.
So, our little data packet, guided by routers and speaking the language of TCP/IP, has traveled all the way across the world and it's just about to arrive. But where exactly is it arriving? What's its final destination?
It's arriving at a server. And this right here is the most fundamental relationship on the internet, the client-server model. It's super simple. Your computer is the client, it's making a request. The powerful computer that has the web page you want is the server, because it serves that information back to you. That's it.
Now, this simple model has evolved into what we all just call the cloud. Instead of every company needing to own and run their own big servers, they can now just rent computing power from massive providers. Okay, let's use a pizza analogy. Infrastructure as a service is like renting a professional kitchen. You get the oven and the workspace, but you bring all your own ingredients. Platform as a service is like getting one of those take-and-bake pizza kits. They give you the dough and sauce, you just add your own toppings. And software as a service, that's just ordering a pizza delivered right to your door. You just use the final product, like Gmail or Netflix.
So, we've followed the entire journey of one single click. Now, let's zoom all the way out and just look at the big picture. How has this invisible architecture, running millions of times a second for billions of people, completely changed our world?
I mean, think about it. This ability to connect has fundamentally rewired society. It's the reason a design team in New York can work in real time with an engineering team in Tokyo. It's how a tiny shop in the middle of nowhere can sell its products to someone in Paris. It's how we can see and talk to our loved ones on the other side of the planet. It's really, truly, the invisible engine of our modern lives.
And here's the part that is just absolutely mind-blowing. That whole journey we just described, your click, leaving your home, crossing the planet through routers and cables, finding a server, and sending all that data all the way back to your screen, that whole thing typically happens in less than 1 second. It's just incredible.
This complex, brilliant, and unbelievably fast system is the foundation that our entire modern world is built on. And by understanding the journey of just one little click, we can start to imagine what incredible new things we're going to build on top of this architecture next. Thanks for joining me on The Explainer.